Next, our presentation entitled Construction of Inhibitory Signal Activated CAR NK Cells and the Application in Hepatocellular Carcinoma Therapy, presented by Yan Lu from Naval Medical University.
Okay, my name is Liu Yan, and I come from Naval Medical School, Shanghai, China. And dear professor, it's a great honor to present our research on construction of inhibitory signal activated CAR NK cell and its application in the treatment of hepatocellular carcinoma. So I will introduce our project from this is 4 aspects. So first, primary liver cancer ranks as the third most lethal malignancy around the world. In 2022, according to WHO, about 410,000 new cases were reported in China. More than half of the patients were diagnosed at an advanced stage, with only 3% of 5-year survival rates. CAR T therapy as a new hope for patients with blood cancer can modify and boost T cell via CAR expression. But however, liver plays as a graveyard for T cell due to poor co-stimulatory molecular expression and high inhibitory signal levels, thus hindering normal CAR T efficacy in hepatocellular carcinoma or HCC. That's why researchers are turning to CAR NK therapy without these obstacles. Besides, CAR NK cell also outperforms CAR T for lack of MHC restrictions, less cytokine storms, and reduced GVHD risks. However, the inhibitory cyclotin T-cell beta within the tumor microenvironment, or TME, will undermine CAR NK therapy through 3 key roles. The first, it recruits and activates fibroblasts that form a stiff extracellular matrix, physically excluding CAR NK cell from the tumor core. And second, it polarizes macrophages toward the immunosuppressive M2 phenotype, which releases additional inhibitory cytokines that dampen NK activity. Third, TGF-beta directly triggers NK cell exhaustion. So here comes the question, that is, how to sustain the cytotoxic activity of the CAR NK cell in the solid tumor microenvironment. For this, we propose developing CAR NK cells that can recognize and convert TGF-beta signals into activating ones to overcome the suppressive liver TME and enhance the anti-tumor activity. To achieve this, we designed a GPC3 targeting CAR NK cells with a chimeric cyclotin activated receptor, which we nominated CCAR. This CCAR has 2 key parts: an extracellular SAFA for TGF-beta binding and an intracellular domain triggering activation. Here is our roadmap. So first, we screen liver cancer cell and pick HepG2 as our target cell for its high expression of TGF-beta. And next, we construct a CAR NK cell with CCAR to recognize TGF-beta and verify the enhanced functions through in vitro and in vivo experiments. And finally, we evaluated the therapeutic safety of our CAR NK cells in vivo. So here is our main results. First, through an online database screening, we identified that GPC3 is highly expressed in HCC and is accompanied by high TGF-beta secretion. Through ELISA and Western blot, we find HepG2 cell line highly expresses TGF-beta, thus serving as our target cells. The conventional second-generation CAR structure mainly consists of an extracellular SAFA, co-stimulatory, and the CD3 zeta signaling domain. This configuration guided our CAR NK design. Accordingly, we constructed CAR NK cells targeting GPC3 and fused the CAR and CCAR sequences via tandem to a peptide, creating a multi-cistronic prescript that boosts construction efficiency. By cell sorting and monoclonal culturing, we obtained our CAR NK cell, which was nominated BBZ CAR NK cell. In cell experiments, our BBZ CAR NK cell showed first an increased phosphorylation level of JAK state and PI3K active signal pathway, which is downstream of the interleukin-2 signaling axis. And second, we further take a closer look at the phenotype, quantifying degranulation CD1078 and cytotoxic granules like granzyme B and perforins, and exhaustion marker TIGIT alongside interferon gamma secretion. The data revealed a more activated and less exhausted phenotype with reduced apoptosis. LDH and flow cytometry assay both showed significantly stronger anti-tumor activity in vitro. And furthermore, we constructed organoids derived from GPC3 positive liver cancer patients. And our BBZ CAR NK cell could also kill the organoids well. And following the in vitro studies, we validated the anti-tumor activity in vivo. In a subcutaneous tumor-bearing mouse model, BBZ CAR NK cells significantly suppressed the tumor growth and prolonged overall survival. Meanwhile, we obtained consistent results in an orthotopic mouse model. Our BBZ CAR NK cell also showed robust anti-tumor activity with minimal side effects. In summary, our research presents a novel approach by developing CAR NK cells that recognize and even convert the inhibitory cyclins like TGF-beta into activating signals. By this way, to prevent exhaustion of cellular drugs in TME and exhibit a potent anti-tumor activity. Our pre-experimental review has already been published on an ACI journal in the Journal of Translational Medicine and awarded in both National Biosynthetic Challenges and Life Science Competition. So thank you for giving me this opportunity to present our project. And thank you again for your attention by the process and looking forward to your feedback.
Guys, any comments? Okay, we're fine then. Okay, thank you once again. Please
Thank you again. Thank you again.
Please give him a round of applause once again.